Okay, the next part of the digitalization of systems and processes within purchasing and supply management in the area of Industry 4.0 module will focus on the digitalization or digital operative procurement processes. So here we will be moving from the strategic sourcing to the operative procurement part, where we look into how technology is changing the ordering within purchase and supply management, the payment processes, or the follow-up and evaluation. When we dive into it, I again explain briefly the technologies, and then I will explain how this helps in the operative procurement part. The artificial intelligence has been described already in the strategic sourcing lecture, and in operative procurement we of course also see the implementation of artificial intelligence in the processes. For example, the overall goal is to automate any transactions in the procurement process. What's necessary for this is the standardization of the processes. We need a good quality of data to do so, and we need the involvement of our partners and suppliers, and we need the involvement of our employees in order to achieve this. We basically can see many fields of applications which run, for example, into intelligent determination of any requirements. So, for example, what kind of delivery schedule we're looking at, or we see an automation of the ordering process, so orders are automatically processed towards the suppliers. We see transport monitoring, for example, of our freight, so we have a deeper understanding of our supply chain and where the products are. And we see a good ramp management, where AI can help us with the ramp management in order to optimize. When we look into the ordering process in the Industry 3.0 case, we would have something like this, a purchasing catalog, where an employee can order any product out of the catalog and then go into the system. So if he would need, for example, duct tape, he can go into the system and order duct tape. Here, the employee is still performing the task of buying the product or ordering that product himself. Nevertheless, we can also move this into a more Industry 4.0 scenario, where we see a high autonomy of the system in order to perform that task, and we see also that the task is more based on a machine-to-machine communication. How does this look like in purchasing and supply management? Let's just take a simple use case. For example, the ordering will be done by a system that is basically monitoring the fill level of the fuel tank. And here we see the fuel tank itself, it filled to a certain level, and we have a sensor here on top which is able to measure the level of the fuel in that tank. In the Industry 3.0 environment, a human would have to check how much fuel is still left, and then after deciding, okay, there's so much fuel left, we need to order new fuel. In this 4.0 environment, the system knows via a sensor how much fuel is still left in the tank, can analyze, for example, how much fuel has been used over the last couple of days, and can also analyze maybe how much fuel we need in the future days due to, for example, production forecasts. Based on the production forecast, it can make an optimal delivery time for the new fuel, and therefore the ordering can be performed by the system. The system will let the supplier know, okay, on that date we expect a new delivery of fuel in order to make sure that we don't run out of fuel and we always have a certain stock level left. So there's no human involvement needed anymore because this can be done completely automated by the system. What do we see more? Robotic process automation. I touched on it briefly already in the previous lecture, but now let's dive into it more detail. What is a robotic process automation? It's basically a software-based technology to automate repetitive tasks. It is rule-based, so we define the rules of the robot beforehand, and it can then be performed by the IT system as a robot. So it mimics basically the behavior of a human. It can press any button, for example, or it can process data sheets, but it's not intelligence in the way that it can adapt to different kinds of scenarios. It always does a repetitive task, which is always exactly the same. We also have different kinds of robots available. So we would have, for example, that we have robots that can help us with chat and communication. We could have voice robots, but we can also have robots that actually perform different kinds of tasks. When we look into RPA, we can also distinguish RPA, robotic process and automation, and intelligent process automation, IPA. And here we can also see how it can be used, for example, in the payment process. So what we see in the RPA, we have a repetitive and structured task performed here, and we can connect this with an intelligent process here, where it can also see ambiguous cases, for example, or identify errors, and that combination allows us to basically enter do the procurement to pay process completely by the system. So RPA is maybe useful to check, for example, what kind of orders came in, what kind of contracts are behind these orders. Is the order fulfilled? In case yes, it is fulfilled, it can move forward the payment process, and so forth and so forth. So for payment processes, RPA can be a good solution. Otherwise, we need to make sure that certain criteria are met for our RPA. So it's not allowed to be highly complex task here. We need a high frequency of the task, otherwise it would not make sense. We need somehow a rule-based process. It needs to be electronic, of course. High volume process is some necessary for this, and high degree of standardization is necessary in order to make the RPA work. When we look into it, we could have used an RPA, for example, in the time of the high inflation rates. Why? When inflation rates are rising, it's quite difficult for the procurement department to exactly know how much a product is going to cost, or how much the buying of a product is at the moment costing. And this is a challenge when, for example, the sales department asks its procurement professionals, what is the price of a certain product today? And then it's the procurement professional would have to make a price request with their suppliers in order to find out did the price change due to the inflation rates already in the last couple of days. And this leads to the fact that you have a lot of manual labor in order to find out how much a certain product is going to cost. Therefore, we could implement an RPA. And robotic process automation in that case would look like that the robot is going to, or is trained or programmed with a certain formula, which includes, for example, price indexes or price lists for a supplier, but also can include any price formulas based on, for example, commodity pricing and globally announced commodity prices for correction, for example. And it can also facilitate the communication to the supplier. So a large part of the RPA can maybe recalculate the price based on existing prices, so openly traded prices, for example, commodity prices of oil, and recalculate the price accordingly before it's communicated to the sales department. In case it is needed to have additional information from the supplier, the robot can facilitate that communication by receiving price statements from the suppliers, and then this price correction will be filled into the formula and then again communicated to the procurement professionals in order to find out what the product costs today. When we look into process automation, we see currently a development from RPA, where RPA is basically automating manual processes into robotic process automation, which is a rule engine in combination with a screen, for example, in order to save time. However, we actually can see that AI is now also involved in this process optimization aspect, because it can combine it with machine learning here, and based on the learning algorithms, business logic, and artificial intelligence, we can have a higher maturity level, more time saved within the optimization of processes, which is highly relevant for the operative procurement part. Going into payment and expecting of orders. So we can also see now when an order is going to arrive. Within operative procurement, we can see, for example, based on RFID technology and text, we can see if a product is already in the harbor or currently on the truck, on the trailer, out of the warehouse. So we have different text available on where a product is. And we can also now move via blockchain basically the bill of lading into a communication structure. So via the blockchain, we can have a good idea about where product is and how the documents are handled, and don't need a lot of manual work on the moving of documents between the exporter and importer. This can now completely be facilitated within the blockchain, saving us maybe 5 to 10 days on communication, but we can have everything available within 10 to 20 seconds. Moving on within operative procurement, we also see something on the follow-up and evaluation and how these orders or its follow-up and evaluation is impacted by technology. For example, within the blockchain case, after a payment is successful, or after a product is bought, we can see that it's moves between buyer and supplier. A lot of information is moved. We see the procure to pay process where purchasing orders are handled, goods are traded, payments are done, and this can be all moved into another system or the blockchain, where we can also include further risk assessment, financing, logistics, and so forth after the product has been bought and learned by the system. So there's a huge implementation of the blockchain technology for storing information, communicating, and also making the link towards the strategic sourcing part. This was a brief overview of the digital procurement or digital operative procurement processes. In the next one, you will have an assignment which is connected to this aspect, assignment 3.1. So I wish you could, I will explain the assignment to you in the next video, and then have good luck with that assignment.